Hey guys, welcome back. Yesterday we finished the last day of new stuff with chapter 5. That was the normal probability plot. So now we're just going to spend 3 days reviewing, and tomorrow and Friday I'll give you guys a practice test. That way you can see what you're going to be expected to know for the test that we take on next Wednesday. Now keep in mind, next Wednesday is September 30th. That is the last day for this unit, so it'll be the last day for you to turn in any homework. So if you have any old homework that you haven't gotten done, or basically it's all going to go into zeros and it's going to go into Power School. So make sure you have all of your unit 1, so the first 5 chapters, make sure you have all of your homework turned in by next Wednesday. And then we're going to start our next unit, which is bivariate data, which is probably one of my favorite units. So anyway, all good stuff. Let's go ahead and get right into this. So we're going to do some univariate data review. We are going to talk about a bakery a little bit, so I got this nice picture for you to look at. Hopefully you're not too hungry now. So you'll notice in the assignment, I've broken down just the general kind of a gist of the information, summary of the information that you're going to need to know. So if you actually read through that information, it'll be a good review for you. And it's got page numbers so you can reference it in the book as well. So a distribution of a quantitative variable slices up all the possible values of the variable into equal width bins and gives the number of values or counts falling into each bin. So when we looked at Mark McGwire's home runs for the different seasons that he had, we had from 0 to 10, but not including 10, 10 to 25, but not including 20, or 10 to 20, not including 20, etc., etc. So we have bin width of 10. So the maximum would go to 70. Well, the 70 actually got put into this bin here because if you notice, this actually goes from 60 up to 70, but not including 70. 70 actually starts the next bin, just like 0 starts this bin here. Okay. So anyway, that's basically what we're taking. We're taking a quantitative variable and we're breaking up into equal width bins. It's not actually categorical, even though we're kind of splitting up into categories of bin widths or whatever. All right, and it also tells us the counts, the numbers that fall into those. We're missing that scale over here because, you know, it came from the calculator, but that's okay. All right, describing distributions. We describe distribution by shape, center spread, and unusual features, which are gaps and outliers. That should all sound familiar to you. For unimodal and symmetric distributions, we can use the mean and standard deviation, which is nice because then we can use a bell curve for it. For skewed data, we use the median and IQR, and for binomial data or anything else, we'll also use the median and IQR. If it's even appropriate. You'll see in one of the problems here about, I guess I can go ahead and tell you, but the one about Old Faithful, number 19, you'll see that we actually want to break it into 2 subcategories, so it's not appropriate to find the mean and standard deviation or the median and IQR for that data because there's 2 groups and we want to go ahead and break it down into the subgroups, then we can analyze it. So if we have bimodal data, usually that means we need to break it down into subgroups and then we can analyze the center and the spread. So that's what this is talking about here. If it's unimodal but skewed, then we use the median IQR and that's totally fine. So on this one here, if we looked at the box plot, it would look like it was more or less symmetrical because the width of the whiskers are about the same. But if you see here, the median is a little bit closer to the first quartile than the third, so that might suggest that it's skewed to the right. And if we look at the histogram, it's even easier to see what's going on. It is unimodal, but skewed to the right slightly. All right, and then also the fence rule for outliers. We find the interquartile range by subtracting the 75 percentile minus the 25 percentile. And then we subtract 1.5 times the IQR from the first quartile and then add it to the third. So if this is our interquartile range here, which is the width of the box, right? We do 1.5 times that width, add it to the third quartile, and subtract it from the first quartile, which will be a negative value. Notice your minimum and your maximum are within the fences, and so there are no outliers on this one here. Okay, and also you don't actually draw this 1.5 times the interquartile range. I'm just showing that. So that's your box plot. That's your modified box plot. I'm just showing it to you just to give you a visual aid of what's actually going on with the formula. So hopefully you'll be able to remember what we do and why we do it with the formula. All right, so we're going to talk about the growth rates for the Southwestern states and also the Northeast Midwest states. They give us the actual data shown in a back-to-back stem and leaf plot, which is nice. You can read about that if you want. And so basically our stem is going down the middle, then we have leaves going to the right for the Southwest states and leaf going to the left for the Northeast Midwest states. Because these share the exact same scale, X scale for our for the population growth rates, that means that we can actually compare them back to back, which is really nice. So you can see that there's much more spread with the Southwest states, and the Northeast, Midwest states are much more consistent, and they're also lower. So you can see that visually with the two shapes shown here. Okay, and there's a key on the bottom. So 66% would be the 6 and the 6, which is the largest growth rate for all the states, it looks like. All right, so on this one, they give us the minimum, first quartile, median, third quartile, maximum. We got to find the IQR, so we're going to subtract the third quartile minus the first quartile, which is going to leave us with 13, right? And then we want to calculate the left and right fence to see if we have any outliers. See if I can get this going. So to do that, we do 13 times 1/2, which is 19.5, add it to the third quartile, which is here, subtract it from the first quartile there, and that's going to give us our values. So let me show you here if we graphed out the box plot, which you're going to do that anyway if you want to go ahead and do it. And so we have a left fence of -9. Okay, well clearly none of them are going to be lower than that. Can't go 0. And the right fence of 43, which we do have an outlier, which is our maximum of 66. So whenever we graph out our box plot, we're going to put an asterisk or a plus sign or a dot, however you want to do it, doesn't really matter, for our outlier because it's a modified box plot. And then the next lowest value, we don't go to the left fence to 43. We actually, because we can look at the data, we know our next one that's not an outlier is going to be 40. So that's going to be our maximum, that's non-outlying maximum, I guess, which is 40. So our whisker is going to go to the 40 instead of going all the way to the 43, which would be our right fence. So we have a right fence of 43 and a left fence of -9. Okay. So when we graph this out, again, we don't graph out the IQR times 1.5. We have our minimum, which is 1. We have 11 or 10.5, which is our first quartile. Median is 15. 23.5, which is third quartile. And then the non-outlying maximum of 40 and the outlying maximum, which would be 65. Any other outliers you'd have, you would also put asterisks for. I think we'll see anything else. Did any of them appear to be outliers? Yes. The maximum was beyond the right fence, VY. All right, now we want to fill in this data into our calculator to find the 5-number summary. So in doing this, we're just doing it for the Northeast Midwest states. I gave you the one that was smaller, so it'd be easier, but make sure you know how to put in the calculator. So stat edit, I put it in list 4. So I started at the top. So 1 and 0 would be 10, 10, 11, 12. So 10, 10, 11, 12. 5, 5, 6, 6, 7, 8, 8, 9, 9, 9, 9, and then 1, 3, 4, 4. So I've got all that right here. And you can double check to make sure you didn't skip anything because there are 19 of them, and that one should say it's the 19th one from list 4. All right, so to find the 5-number summary, we go to stat, arrow over to calculate, one variable stats, and we're going to do it for list 4 for this one. Then hit calculate. We don't want the mean and standard deviation. That would be 7, standard deviation of 2.94. Well, we want the 5-number summary because we're doing a box plot. So our minimum is 1, 5, 8, 9, 12. So that's these 5 right here, 5-number summary. 1, 5, 8, 9, 12. And those are the 5 that we graph out here. So 1, first quartile is 5, 9, or 8, 9, and then the maximum is 12. And if we look at this, we could find check to see if there's any outliers. Our interquartile range is 4. 1.5 times 4 is 6. Add 6 to 9 is going to be 15, and subtracted from 5 would be -1. So clearly our left and our right fence, our maximum and minimum are within those, so there are no outliers for the Northeast Midwest states. All right, comparing these two distributions. So what do you notice? Well, we notice that, and we could even see it here, right? The population growth rates for the Northeast Midwest region states is going to be much lower than the Southwest states, which are growing much more rapidly. There's also, they're more consistent. There's much more spread and variability with the Southwest states. It looks like the Northeast Midwest states is actually slightly skewed to the left. The left whisker is a little bit longer than the right whisker, and the median is closer to the third quartile than the first quartile. So it's slightly skewed left. But for the Southwest states, it's clearly skewed to the right, not only by the outliers, but also the whisker is longer and the median is closer to the first quartile than the third. So they're skewed in the opposite directions. One of them has much larger spread. This one is much smaller spread, much more consistent. And you can even say how much taller it is. The upper 50% of Southwest states are entirely above all of the growth rates for the Northeast Midwest states. So you can pick any line here and then kind of compare it however you want to do it. There's lots of different ways to summarize it. All right, box plots summarize one variable quantitative data using quartiles, which means the 5-number summary minimum, so 0, 25, 50, 75 percentile, and then the maximum. Modified box plots show the outliers as dots beyond the whiskers with the max and the minimum. We always use the modified box plots. So if we're looking at our different graphs here, our modified box plot is the 4th option, where we don't use the 5th option because that's just a normal box plot. We always want it to check for outliers for us, essentially. Our example 2, here are box plots of the points scored during the first 10 games of the season by both Cyrene and Alexandra. Summarize the similarities and the differences of their performance so far. So here we have the number of points scored per game. So it looks like these are going by five. So it looks like the minimum for Alexandra, one game she only scored 5 points, but she had a maximum of like 28 points. So, but with Cyrene, her minimum was like 15, her maximum was 20. So how do we compare and contrast these two players? Well, if I'm looking at Cyrene, I notice that she's much more consistent of a player, right? She always scored between 15 and 20 points. So that's good. But with Alexandra, she has good days and really bad days. There's much more variation in the amount of points that she scores, anywhere from 5 all the way up to 28. So there's similarities. Looks like their medians are exactly the same. So their middle 50% of games, they would score exactly the same, about, I don't know, looks like 17 points. So they have the same median. They're also both symmetrical. Neither of the distributions look skewed. Maybe this one you could say is slightly skewed to the right because the right whisker is bigger than the left, but it's really small. The differences are going to be in the spread. Cyrene is a much more consistent player than Alexandra. And if a coach could only take one player to state champions, which one would you take? I would take the more consistent player, right? If it would be a different story if she was consistent and not as good, but I would take the more consistent player because I'm looking for consistency from game to game for our championship. All right, Clarksburg Bakery, that's why we had all the bread at the beginning, is trying to predict how many loaves to bake. In the last 100 days, they have sold anywhere between 95 and 140 loaves per day. So notice here, this is not going from 0. There's a jump in the data, so 95 all the way up to 145. This goes 145. If we go 95, 100, 105, 110, 115, 120. So these are going bin size of 5. So this 140 actually got put in this bin over here, even though, technically it would be right there. So just kind of a downside. All right, describe the shape, center, spread, and unusual features for the distribution. All right, so the shape is unimodal. The center is, so it's obviously unimodal and skewed to the right, follow the tail to the right. The center and the spread, we could estimate, if it's skewed to the right, we would use the median and the IQR, right? So we're going to estimate the median, which is going to be equal area. So this area is equal to that area. So it's probably going to be closer to here. So maybe about 103, maybe even 100. I'm not sure. So yeah, it could be 100. The IQR is going to be pretty small. So I'm going to go with an interquartile range of 10. Spread and unusual features. We probably have some outliers here. The data is definitely skewed. There's no gaps in the data. It's not like there's gaps between two groups of data. Which should be larger, the mean or the median? Well, we're going to use the median because it's not impacted by the skewedness. The mean is going to be impacted by these larger days, which the whole graph is skewed to the right. So our mean is going to be higher than our median because it's impacted and skewed to the right. Uses summary statistics for Clarksburg Bakery bread sales to calculate the right fence, then create a modified box plot in the histogram or below the histogram. So we're going to take our interquartile range, which is the 75th minus the 25th. I'll just put it in the calculator real quick. I'm going to do second mode to quit out of that one. All right, so we're going to do 105.5 minus 97. That's going to be our IQR. Multiply that by 1.5, which is 12.75. And then I'll show my work over here. So take the third quartile, add the 1.5 times IQR to it, which will give us our right fence of 118.25. And if we look at our maximum, of course, that's going to be beyond that right fence. So graphing it out, our minimum's at 95. Our first quartile's at 97. Third quartile, I missed the median. The median is 100. So that's going to be right here. Okay, no big deal. Our third quartile is going to be, third quartile is going to be at 105.5, which is roughly about right there, just slightly beyond that one. Then maximum is 140, but keep in mind those are going to be outliers. In fact, there's one in each one of these bins at least. It looks like there's just one day, right? And then there were several in this one, and then our maximum without being an outlier when we added to the third quartile was 118. So that's going to be about right here. So that's where we're going to put the end of our whisker. We're going to assume there's one close to there. Of course, it would be moving forward or backward depending on what the actual data was, but we're just going to put it to the end of that one and then put all of these, and we don't know how many or where they're at, so I'm just estimating, put a bunch of dots here and then one in each one of these bins going across there. Okay, so graph that underneath there so you can see go off the scale pretty easily. All right, for the data, the mean was 103. So that means our median would be less than 103, right? So our median is going to be less than 103. Probably 100 would be better. With standard deviation of 9, do the statistics suggest that the Clarksburg bakery should expect to sell between one standard deviation from the mean on about 68% of the days? So the reason we can't use a bell curve, right? So if we centered it at 103 with standard deviation of 9, then between 94 and 112, that would be 68%. That's the empirical rule, right? But the reason why we can't trust that is because it's not appropriate. Check this out. It's so cool. It's not appropriate for us to fit a bell curve on data that's not unimodal and symmetric. So clearly, this is not going to be right. And then you have all this data that nothing's filled in, and then all the gaps here, and that's way above it. So it's clear it won't fit. But what I did there, let me actually kind of show you, is I graphed out the mean of 103, standard deviation of 9, so I went up to, it'll be 112, so I went up to 112. And so that's our mean and our first one standard deviation to the right. If I match it up here, sure enough, that's our mean at 103 with a standard deviation up to 112 here. So that is what it would look like, and clearly it's not going to work. We're not going to see 68% of the data within one standard deviation. It looks like it's going to be much more than 68% of the data because there's nothing beyond the tail, one standard deviation here, and beyond one standard deviation here, there's quite a bit, but not as much as the gaps that we had on the other side. So anyway, that's why it's not going to be appropriate, because it's not appropriate to use a bell curve when we have skewed data like we have here. We would use mean and IQR, median and IQR. All right, number 35. I'm not going to go through the whole thing. I'm just going to show you part of what you're going to do to break it down. So we're looking at the voter age brackets. This is a contingency table here, and I guess I'll read this. A segmented bar chart displays conditional distribution of a categorical variable within the category of another variable. So what we're going to do is, if you notice here, we're breaking down by voter age bracket or voter age bucket or group here. So this is our category. So it is age is a quantitative variable, but we're breaking down to a categorical variable because we broke them down into these little brackets. So it's one of those, could go either way, but that's fine. So we have our 18 to 29-year-old voters, and we wanted to know what is the distribution of their political party affiliation. So we had 318 out of 815 voters, which is 39% were Republican or leaning Republican, 52% Democrat or leaning Democrat, and 9% were neither. And so what I'm going to do is give you a key. So with each one of these categories I'm graphing out, I did the colors, which, are the colors that you would kind of associate with those anyway. So it helps it interpret. So our first 39% is going to be conservative, 52% is going to be Democrat, and the top 9%, so you could add those two percentages to figure out where it goes or whatever, but the top, I knew I had to go top 9% was going to be neither. Then you'll do the same thing for the other two. So we're going to take this this conditional distribution of party by age bracket, and you're going to do the same thing and break it down for the other two groups, or the other three age brackets, and you'll fill in the rest of that. Okay, and then the problem above that you guys should be pretty good on. And yeah, that's pretty much it. I even went over this one, which was an odd problem, but I did all the even ones with you, so you should be able to get through the odd problems. It's kind of a shorter day today, nothing really new. Of course I'll be on the live chat or whatever, not the live chat, sorry, our Google Meets live office hours from 1 o'clock to 2 o'clock. If you have any questions on any of the stuff, I can go through it. So take advantage of that. Also, make sure you're getting caught up on your homework, because Wednesday's the last day to turn in all the unit homework. And we are going to take a practice test tomorrow, so you'll know exactly what you need to be ready for over the weekends to study more. And yeah, so yeah, good stuff. I'll see you guys later. Have a good day.